the questions easily, I guess.
Mostly theoretical based questions will be there.
Actually, this time actually we have solved some problems. So maybe formulae, or you may say answer of a question.
Okay, sir.
So this is the only PPT, not PPT, you may say this is the PDF that we have completed after the CA1. I hope I'm correct. We have only gone through this much, this introduction to FEM. Whatever we have completed till last class, I think that is the thing. Na? We have not completed anything else, any other PPT or like that, right? So whatever will be questions, it will be from here. Okay. But yes, in this case, please go through the each and every point, because here nothing is explanatory, everything is to the point. So it is a precise note basically. It comprises of you must say the history in a gist form, then what are the general steps, how to select elements, okay, how to number them, then after completing that, how to select the displacement functions. Once you have selected the displacement functions, how to uh, find out the various relationships, relationship between displacement and strain and stress. Okay, then development of the stiffness matrix. So for the development of the stiffness matrix, there are a number of ways. Direct equilibrium method that we have already discussed in the previous, you may say, introduction to the linear algebra. There also we have discussed that. Now the variational and weight-based methods, they are a little bit complex, but yes, we have to go through them. We don't have any other option. Okay, so we have um, the next part of this notes. This is basically a notes. Whatever I have provided you, this is the note of a university. So this is in gist for my thought to give it to you, so that you don't have to go through large books. If you wish, you can go. Then that's great. But it should not be a compulsory effort for all of you. Those who are interested in FEM, they can go for more details into the books. Otherwise, I hope this has provided everything in a gist form, and we can utilize it. So after generating the stiffness matrix for the element, then you have to combine it using the superposition principle. I hope you remember the superposition principle. We had solved some questions in case of the spring. In case of the spring problems, we had solved some. Oh, just a minute. Sorry, let's record it so that it will be easy for students. Oh, good. Someone has started recording. Thank you. So the thing is, uh, we have gone through such questions where we had used superposition principle to calculate the global stiffness matrix for one element, then two element, then three element, then four elements. How we can derive it instead of explicitly calculating it. Okay. Then we have to apply the values of either the initial value or the final value problems. Okay, so we have to apply the initial value as well as the final value if it is available. Then after that we get, if you remember, we'll get the complementary function. Okay, whatever we saw in the last class. So after solving the complementary function, you will find the general solution. Okay, we'll get the unknown things that are needed to be known at the end. Then after you have known the unknown, then it needs interpretation. Means what is the meaning of whatever we got the output, even if stress has developed, if any strain has taken place, So if anything has done, then what is its significance? Because here we are trying to solve a geometry or trying to solve the deformation or the, you may say, the reaction force developed, the stress developed across a geometry, and the geometry has physical significance. It may be aeroplane parts, it may be a fluid flow situation, anything it may be. So interpretation is also important here after completion of the analysis. Then we went in more details for which types of elements and how we can select an element, or what are the basic characteristics of an element. We went through that. We also came across, after we identify the elements, we have to know that the element is made up of nodes, okay, and you know that you have to segregate the entire structure or entire, you may say, the geometry into your elements and nodes, okay. So it is of two ways. One is natural. In case of truss, the elements are already available, you don't have to imagine anything, you just have to number them. But in case of heavier structures, like sometimes concrete dam or plates, etc., we don't have any physical elements that can be directly identified from the geometry. So in that case, the situation is a little bit complex. We have to go through imagination. So when we imagine, there are a number of ways we can imagine a structure to be filled with the elements. Someone may imagine triangular elements, someone may imagine rectangular, or someone may imagine quadrilateral, someone may imagine any other element. Then also we came across that a number of ways are available. It may happen that different types of elements are used uh, for discretization, or you may say that there are different ways, there are maybe multiple ways with which we can represent the structure. Then you also came across that sometimes, as I mentioned, we have different options, different types of elements that we can use. So there are cases for that. Now, once we are able to decide how to discretize it into a number of elements, then we have to think regarding what is the size of the elements, what is going to be the size of the elements, because it's an important criteria. If your size is very small, that means your result will be very precise, your result will be very close to the accurate result. However, the computational burden will be increased. So it's a basically trade-off, it's basically a compromise between how much accuracy you want and how much computational burden you can handle, or the computer can handle. That depends on that. So you have to make a good judgment, okay. And in some cases there are situations where the structure has discontinuity, means the structure is regular geometry, after some time or after moving in certain direction, sudden there is a abrupt change in the size of the, or in the dimension of the material or the element. In such cases, you have to place new nodes, okay. uh, what we have seen here, that we have to place new nodes, and then we came across the various types of problems. तो इस साइड को थोड़ा बंद कर देने से चलेगा, ये वाला को थोड़ा बंद कर देने से, और ठंड लगता है एक्चुअली, वो धीरे धीरे सूख जाएगा. सो next there were some applications, because we know that after we do of all these things, the next thing is to solve it once we generate the equation, the next work will be to solve it, and in such cases we will be provided with इस साइड में होगा, इस साइड में, अपोजिट साइड में, हाँ वहाँ पे कुछ एक होगा. So as we came to know that when we are given with some conditions, the conditions may be initial value, that means the value of the dependent variable y and its successive derivatives are given at a specific point, or it may happen that we are provided with the value of the dependent variable at different points of, or at different values of the known variable. Okay, based on that you can segregate your you may say the problems with given conditions into either initial value or boundary value problems, and then we went across problems. Okay, so I wish that you can expect some problems in the exam. So we have a question and you have to calculate the answer. The answer will be given in one of the options and you have to select it. Okay, so you can use your pen and paper at home to practice the questions, and you just have to upload you have to just select the correct answer after calculating the things. So here what we saw that you have to write the differential equation, you have to write the conditions, and the most important thing then was to use the auxiliary equation. So whenever we are going to solve the differential equation, we have to take the help of the auxiliary equations. Auxiliary equations are derived by replacing the derivative of the dependent variable d by dx with lambda. Okay, so you can generate the auxiliary equations, or sometimes it is called as the, you may say, characteristics equations also. So we have to get the auxiliary equation. We have to take the auxiliary equation to get the value of lambda. Once we know the value of lambda, then we will have the complementary function, and using the complementary function again you have to put the value of the unknowns. Okay, then we will get the final solution, or you must say the general solution. Okay, so this is for your initial value problems. However, we'll have we went through a few questions here. One question where we had a first order derivative. The differential equation consisted of first order derivative of the dependent variable. In question 2, here it is in the slide, you can see that we have second order derivative. Then we have questions related to boundary value problems, but the approach is the same. We have to again define the auxiliary equations, find the value of lambda, define the complementary function, then put the value of the boundary conditions, and finally get the value of the general equation. Okay. So this much we have completed. It's not much actually. It's a very small portion. And then we went through the eigenvalue problems, and in the eigenvalue programs, what we had discussed, that the dependent variable and its successive derivatives, first order and second order derivatives, they are multiplied with a function. They are not multiplied with a coefficient, numeric coefficient. They are multiplied with a function, which is a function of lambda as well as the independent variable x. Okay. So in such cases, the complexity arises, because now when you use the auxiliary equation or the auxiliary equation, at the time you will find the value of lambda as a unknown. Earlier you were getting the value of lambda to be known, or you may say, since lambda is a constant here, so in this case we will use the value m to denote the, you may say, the characteristics function. So it's an example. We have a question, boundary conditions are given, and we have the auxiliary equations by replacing m by replacing y in terms of m, where m is the same as the lambda in the previous examples. Okay, because since here already lambda is a constant, it is mentioned as a constant in the eigenvalue problems, so we have to use another name or another symbol m to identify the unknown or the dependent variable. So we'll have question for that. We have gone through two questions actually, but here the complexity arises because now the coefficients are functions, right? So obviously the complexity little bit arises. We have to solve the questions in a lengthy manner to get the answer. And from here we were expected to start newly, but I feel we should not start it here. Okay, we'll start it after the exam. Okay, so some more concepts are there. See, here it is looking like lengthy because you see only one question is taking around 2 pages. Okay, more than 2 pages sometimes also. So hence it is looking like that. Otherwise, not an issue. You can complete it in a very, you may say, early manner. But anyway, we will have some questions. There are many questions here. We cannot solve all of them. But yes, we will definitely solve some questions. And then some more concepts are there. Okay. And we will close the chapter. From the map chapter 1 onwards, what we will do, whatever we have learned here, now we will start applying that to different different geometries. We'll start with truss, then beam, then thermal analysis, uh, then your symmetric is axisymmetric 3D models or 3D objects. So there are the things. Then we'll go one by one application. But this chapter lays the foundation for the upcoming chapters. So I wish all of you to go through it properly. Okay, so that after your exams are over, we'll move forward very properly. So I have given you a gist of whatever we have studied, and since it is a small syllabus, I hope you all can do well. And any questions? What I reviewed today? Any questions? Okay, if there is no question, then I think you can utilize the time in your preparation also. Okay, we'll stop here for today's class, and
So,
the
so for
next.
the CA2, none of the big
Yes,
numericals
yes,
will
yes,
come,
yes,
which we
yes.
covered.
15 marks, similar to the previous one. Ah. We'll have 9 questions, 1 mark each, and 3 questions, 2 mark each. Same, similar. So, okay, so wish you all the best. And during the preparation, if you get any confusion, anyway, I have just reviewed the process, whatever you studied in the last few classes. But anyway, if you face any problem during the solving questions, you can take the help of your friends. Maybe you can do group study, or if you still are not able to solve, you can message me. We all are in the group, right? So if you face any problem, you can let me know also. I'll be also helping you out. Okay. So uh, if there is no question, then I think we can close the session here. It's okay. And I have a request, please upload all the videos, or if you get time, please upload all the videos into the folder, है ना? Because this will be useful later. Okay. So with this, let's conclude this class, and we'll meet at the time of exam. So you all are requested to uh, be ready for the exam at the scheduled time, at least 3 4 5 minutes before the scheduled time. Okay, so let's close the meeting then. Thank you all.
Thank you, sir.
Thank you, sir.